providers are rushing to provide services, Google, Microsoft, and even Amazon. And so machine learning as a service is now very, very common in cloud. And this is a diagram I took from the Amazon's webpage that you notice that all this familiar AWS service, but plus Amazon CloudWatch and Amazon Machine Learning, everything like that. Everybody is rushing to provide the services. Why are they so eager to provide the service? Although the technology is still changing very fast, because they want to get as many users to their cloud as possible, and then by this many users, they accumulate user data, big data. In the future, I think the hardware and the software in the AI world, they are competing against each other. And if you look at how intelligent the hardware and software piece is, it's actually based on how comprehensive the learning base is. So that comes to how much big data you can gather in terms of getting it to feed, to really incubate the artificial intelligence, okay? And also, you see a battle for acquiring innovations. I mentioned earlier that Google didn't have the team to come up with the AlphaGo. It spent $600 million US. Intel, I mentioned earlier that Intel had acquired two companies. Nirvana is a hardware plus software company, $400 million US for acquisition. Also, this Altera, even more, 16.7 billion. That's a huge amount of money, right? So a battle to acquire innovations. Innovation in-house, not enough. Try to get all the innovation you see outside your company so that you don't lose the chance. Facebook, the flagship software of Facebook is called Cafe 2. The original version was Cafe. Cafe was an open source software developed by a student from China in UC Berkeley Electrical Engineering when he was a student there. So again, Facebook did not invent or develop their in-house artificial intelligence software by themselves. Apple, the most noticeable feature of Apple's cell phone is how they recognize your face. Well, they didn't develop that function in-house either. They acquired these two companies, Emotion for facial expressions and Turi with $200 million US for machine learning. So as I said earlier that despite all this software talents, all this company, or the hardware talents, all this company can recruit, hire, but obviously for the major innovations, they acquire from the market instead of developing in-house. So this tells us that new startups in all this area have a chance, a very good chance. Not to become another Google or Facebook, but be acquired with a very good sum of money. Okay? And also the boundary of hardware and software is blurring. Look at Intel. Intel earlier, some years ago, acquired this Israeli company, Mobileye. At the time of acquisition, Mobileye was the biggest single case of acquisition in Intel's history. It was reported widely in the media. And Mobileye is very, very well known in the autonomous driving area. And the acquisition was US 15.2 billion. But not long after, I mentioned earlier that Intel spent even more to acquire Altera, right? And 400 million, Nirvana, well, Nirvana is a hardware plus software company. And now the mainstream software for Intel in the artificial intelligence, Neon and Ngraph, actually come from Nirvana, right? And then NVIDIA's and big deep learning, reinforced learning coach. All this software you can check in the open source world from Intel. Google developed hardware, TPU. Microsoft developed hardware, brainwave. So you see Intel is crossing into the area of software. Google and Microsoft is also going into the area of hardware. Why are they doing this? I think behind all this blurring of the boundaries is integration, vertical integration. My good friend here, Maverick, his father Stan, a very good friend of mine, talk about horizontal integration, expand the horizontal scale, but and also Wang Dao, you know Wang Dao, right? Don't do vertical integration and control everything, but unfortunately, this is not happening here. Everybody is trying to do vertical integration, try to secure hardware, software, and then up into applications. Let me show you this slide here. From NVIDIA, last year, it held a contest, what they call the Identify New Startup for the Most Social Impact. More than 600 companies entered, took part in the competition. And the top 5 winners emerged. Look at all these top 5. Happens to be all medical services application. I won't go into detail, just show you the 5 companies. One from South Korea, one from India, and the other 3 are US companies. And all medical companies, as I said, Geneticist, a biomagnetic imaging system that monitors the weak magnetic field from the chest and generates a 3D map of the heart, and so on and so on. Okay? So this is an example how a hardware company, AI chip company like NVIDIA, not only develop their own software, but also encourage or incubate applications. So again, what is happening in the field is what I call vertical integration. They want to secure, hardware companies want to secure software, software companies want to secure hardware, and all of them want to secure as many applications in their hands as possible. So NVIDIA is one example. Okay. And also the business model of how the software is changing. How do you judge the value of a software? Well, to take, say, Microsoft Office as an example. The functionality of the Microsoft Office is very comprehensive. It has all the features you need, but that's what I call functionality based. If you look at the antivirus system, it's not functionality based. It's a very straightforward function, software function. Just take a sample of a virus and compare it throughout your files to see if the file contains a certain pattern of a virus. If it does, and then you have the virus in your computer file. That's very simple. Everybody can do that. But the core is how complete your virus database is. That's intelligence. That's not functionality. That's intelligence. So in the future, I feel that the software value is really judged by intelligence and not by functionalities. How do you really build intelligence? Well, you gather all this data from the internet and then try to get the virus pattern in terms of antivirus. Also, open source becomes dominant compared to, say, commercial software, right? Why is everybody pushing their software into the open source community? Because they want to get, as I said earlier, get many users, accumulate big data, and big data allows you a more comprehensive learning base and more intelligence. Are you going to sell your software for money in the future? Mostly no. You get your software to the open source. You try to get as much intelligence into your software as possible, and then you figure out if you can get some money from the follow-up services, but not from the software itself alone. So the business model will also be changing. Of course, this poses a challenge for companies like IBM or Microsoft, because in the future, it's not a matter of selling software. It's a matter of getting you to use their software for free, and then later try to come up with ideas about add-on services. Okay, implications, application-centric and domain know-how. Okay, this is what I'm going to talk about in later. In the mobile and IoT world, GPU is already very commonplace in your cell phone. Maybe you know, maybe you don't realize that you do have a GPU in your cell phone so that you can watch YouTube very, very smoothly, right? And then Apple and Huawei both announced that they would have dedicated AI area in their chips. Not AI chips yet, but in their hardware design, part of the circuit will be dedicated to process AI work. Okay? I see in the future that they will eventually evolve into AI chips in the cell phone too. And why are they doing all this? You have this cloud in the back, and then the cloud is so powerful. It has all this intelligence. You can just pass your information back to the cloud, allow the cloud to process the AI analysis. But why are you not doing that and really want to focus the AI process locally in your cell phone? Because first of all, you want to save the bandwidth and traveling time of the data. Second of all, privacy and security. It's better that you can handle all this AI application locally in your cell phone other than passing it back to the cloud, right? One very challenging question is, would Apple or Huawei open up their API for their hardware so that new apps could be developed for the iPhone and Huawei? That's a very challenging question. Initially, from what we see now, no, they are not opening up their APIs. I think eventually they will open up, but now it doesn't seem so. If you look back to the history of Apple and apps, okay, Steve Jobs, when they first came up with the iPhone, Steve Jobs insisted a very closed system. He didn't want the application interface to be open, and so Apple once tried to develop all the possible applications by themselves, but Steve Jobs was convinced by his colleague that this is not the way to go. Apple should really open up an interface so that everybody could develop apps on iPhone. That's why you see all this proliferation of apps, not only on Apple, but also on Android phones. That's a very major milestone. We see that sometime in the future, that eventually I think Apple or Huawei would also open up the API for AI-based apps, but maybe not now. They want to secure their own position first. So we will see. Okay, now that was a very quick overview of what my observation is. As I said earlier, that you guys in Silicon Valley, you have the environment and also the connection to see more in depth. But this is my very superficial observation. And then I'd like to really propose how Taiwan is to undertake this ABCD challenge. Taiwan has some advantages, but does it have some advantage? For example, Taiwan has all the ICT, OEMs, OPM. We have TSMC, UMC, all the leading fabs. We have MediaTek for cell phone chip design, Acer, Asus, and HTC, all major brands of ICT products. But all of them are facing challenge. I think Maverick is leading part of the Acer's activity in going out of the traditional laptop hardware and going to more servers. Okay, so they are good in the past, but all of them are facing very, very severe challenge right now. And but on the other hand, Taiwan has very good what I call domain expertise in certain areas: manufacturing, not only semiconductor but mechanical manufacturing, medical services, and also agriculture. Taiwan do not have the making design of general purpose CPUs. I remember many, many years ago, Gong Yuan Yitri tried to develop a CPU chip, but it didn't fly, right? If you talk about general purpose CPU, we talk about Intel dominant, we talk about AMD, but no others. I think this is a matter of not only the technology of design the CPU chip, it's also a matter of marketing, the marketing of the hardware. You want to promote your product all over the world, and that's what Taiwan is lacking very, very seriously. Okay, and also Taiwan missed the chance of ICT software and services. Taiwan is very good in hardware. I mentioned OEM, ODMs, but it's a very pity that Taiwan missed the chance of the software and the service area, especially the internet service area. So I'd like to propose a strategy statement that Taiwan should forget about general mass market. Stay away from general mass market like laptop or cell phones and go into niche. Look for opportunities in the IoT edge device because IoT edge is highly related to applications, and it's a niche market, okay? And service-oriented, I mentioned Maverick for a very good example. Acer is a very typical motivation to move into the service area. Domain-centric applications, look for significant entry barrier. I mentioned earlier that Taiwan is good in manufacturing, either semiconductor, mechanical. They are both industries with high entry barriers. Medical service, high entry barriers. Agriculture, high entry barriers too. So look for area of high significant entry barrier and areas where it was not replicable before, but replicable now because of AI. Take again, medical service for example. Taiwan University's previous president, Yang Hanci, a very well-known doctor for lung cancer. He can only see patients in Taiwan. He is not able to see patients here in Silicon Valley, not replicable. But if his experience of diagnosing lung cancer can be put into an AI module, his experience can be replicable everywhere in the world, including here in Silicon Valley. So if we can convince Dr. Yang that after his presidency, he should go to work with an AI expert and convert his experience and knowledge of lung cancer into an AI module, I think he could make very good money. Okay, I'm actually going to my next slide. Okay, so medical service. Try to get an open source platform, very easy to get from open source community. Develop the AI application, medical for example, leverage the experience from Yang Hanci, and then finally, if he was able to have this AI module done, then the next critical question is business model. How will you replicate Yang Hanci's know-how? And how will you really allow Yang Hanci or Taiwan University to make some money, actually, hopefully a lot of money on this business model? Well, my previous slide said, well, try to bundle with hardware. Medical devices, three major companies, GPS, General Electric, Philips, Siemens, GPS. Try to work with one of them. Say, well, your machine is not machine right now. Just scan pictures, and then allow the radiologist to look at the picture and see if there's lung cancer for this patient. Well, maybe you can bundle your machine, currently a dumb machine, bundle Yang Hanci's AI module into your dumb machine so that it becomes an intelligent machine. And then once you produce the scan of a lung, the Yang Hanci's module will give you a prediction, well, 80% of the chance this patient has lung cancer. And then you have another radiologist to really make sure that the Yang Hanci's AI module is predicting correctly or not. For each prediction or each diagnostic, maybe Yang Hanci can charge $100 or I don't know. How much you pay for a lung scan if you're suspecting you've got lung cancer, right? Definitely more than $100. So I think it's fair that Yang Hanci share $100 for each scan diagnostic, right? And also Yang Hanci's intelligence will also improve by the time because he's still continuing to see patients, and then so this is where the intelligence come in. Just like you're updating your virus database from internet from time to time in your antivirus software. GPS could update by internet Yang Hanci's latest diagnostic know-how in the AI module and charge them again for this updating. So this is a business model that I really like to see in the future. And this is time critical because if Yang Hanci is not doing this, I bet many famous lung cancer doctors in US or Japan is doing it right now. So we are competing with the time. Okay? So we really should try to persuade all the well-known famous doctors in Taiwan that see less patients, spare some time, work with AI experts, and try to work out this intelligent diagnostic module for medical services. Autonomous driving. We mentioned earlier that this Mobileye was acquired by Intel for a huge sum of money. Okay. Let's look at Tesla and Google, the company Waymo under Google. It's very easy to notice Google's self-driving car on the freeway here, around here, right? Up to the end of 2016, Google accumulated 1.6 million miles of driving data for learning the autonomous driving intelligence. But Tesla has more. Tesla accumulated 1.3 billion miles because Tesla cars are already on the market. So some of you, I guess, Tesla cars, when you're driving a Tesla car, it's recording all the road conditions and upload it to Tesla and allow Tesla to use that for learning autonomous driving. And if you look at the traditional car companies like Ford, GM, they acquire different companies, all with big sum of money, US $1 billion each, Ford or General Motors. And if you look at some of the other companies, Volkswagen, Toyota, all reported their R&D of the autonomous driving are reaching billion-dollar scale. Even Baidu, the search company in China, are said to invest 20 billion renminbi on a project called Apollo of autonomous driving. Okay? So what am I trying to say here? I'm trying to say, can Taiwan also accumulate or spend all the money to develop autonomous driving? No. The bottom line is this is not the game Taiwan can play alone. Okay, so if Taiwan's government say we want to develop a autonomous driving intelligence from scratch by Taiwan alone, I say forget it. Don't try it. Don't even try it. Okay, this is maybe not pleasant for Taiwan's government, but this is, I think, the true truth that I like to point out. And if you look at this chart by Navigant Research this year, how good is the strategy of different car companies and how good they can execute? Very unfortunately, Tesla sits on the bottom. I guess most of you know that Tesla has problems in manufacturing all the cars that it's receiving order, right? So Baidu is not doing very well either. If you look at the chart, the bottom, the upper right corner is the companies that are doing well. Google is doing quite well, but if you look at the other players here, General Motors, Ford, okay, the two major US companies, Daimler, Benz, Volkswagen, BMW, the major European companies, but no Japanese companies. Toyota is here. Sadly, Honda is even worse. Nissan is doing better, but all the Japanese companies are not in the top quadrant, right? What's your interpretation of this chart? My interpretation of the chart is that, well, it may be companies like Google, Tesla that can do very well in developing the autonomous driving technology. Ford and General Motors doesn't have the talents to develop the technology, so they acquire. But once they acquire, those traditional car companies, manufacturing companies, are very good in discipline, in execution. So once they get the technology, they can do very well. Okay? So likewise, all the European companies, Volkswagen, BMW. But people will say, well, Japanese are very skillful and very disciplined as well, right? Maybe so, but not the young generation Japanese anymore. The young generation Japanese in Japan, if you have friends there, they are not like the older Japanese that we think are disciplined. They are not, I wouldn't say not disciplined, they are less disciplined, okay? So what's the implication for Taiwan here? Well, Taiwan obviously doesn't have any company that can go into the chart, but if we do, then obviously our strength is that our manufacturing-based industry should try to maintain, or we already have the discipline to execute the technology that we acquire. This is our opportunity. So I hope that our young generation in Taiwan are better disciplined than Japanese young generation. Okay, so this is my recommendation. What is the unique feature of Taiwan's traffic? Well, Tesla is now selling in Taiwan too. If you are driving a Tesla car in Taiwan, would you dare activate the self-driving function of Tesla in Taiwan? Obviously not, because the learning of the Tesla driving, self-driving, hasn't experienced on the scooters, bicycles around you, right? When you stop in front of the red light, all the scooters surround you, right? So closely, maybe less value-add module of self-driving in this kind of a mixed traffic environment. Okay, so my recommendation is try to work with all these companies. Say, well, if you want to sell your car into Southeast Asia and face all this difficult driving condition, Taiwan can help you to add the intelligence. This is what I'm saying. Okay, and then of course business model. if we were able to develop all this model, how would we charge Tesla or charge Google? Well, obviously, we can license the technology, or we can do profit sharing, so that's a very typical business arrangement. Okay, no need to really market your technology all over the place, because you basically have Tesla or Baidu or whoever that's carrying your technology to promote your technology everywhere. Let me show you another example, agriculture. A young farmer I know in Hualien did this last year. He is helping his father to grow watermelon in Hualien. Just last weekend, President Ma Ying-jeou went to Yuli and helped sell the first watermelon. The watermelon season is here. So last weekend, Yuli, a watermelon in Yuli is on the market. And Ma Ying-jeou went there to help sell the watermelon. For 20-some kilo watermelon, guess how much Ma Ying-jeou sell for the farmer? $600 US. $600 US for the first watermelon from Yuli last weekend. Okay, that's how much Ma Ying-jeou is worth, right? I'm joking. Anyway, next weekend when I return to Taiwan, I would also go to Fenglin, another town in Hualien, and also pick watermelon there. Oh, 徐大林博士来了. Please have a seat. Long-time friend. Okay, so this young farmer, his problem was about this time last year. He helped his father to grow thousands of watermelons. And when he comes to this time of the year, he's going to harvest the watermelon. The first question, this is the first time, the first year, he encountered this watermelon harvesting problem. How many watermelon do you have in your land? Okay, so he bought this drone and have the drone fly over the watermelon field and take this picture. Of course, from human eye, you can identify very clearly that, okay, one here, one here, one here, right? And this is, and some of them maybe say this one is not a watermelon, this one's a rock, right? So the problem is, once you take this picture from a drone flying over the watermelon field, how do you identify which one, how many watermelon you have in the field? So this young farmer, although he has no background in computer science at all, he went to the open source and identified one software from NIH, National Institute of Health, from US government. You know NIH, right? Amazingly, a software from NIH called ImageJ. ImageJ. That's a software a scholar used to study pictures from a cell, biology cells. If you want to count how many cells you have in one picture taken from, say, a body, you use ImageJ to count how many cells. That same software, ImageJ, could be used to count watermelon. Just take each watermelon is one single cell. You tell how big, how many pixels a single cell is, and then ImageJ would do exactly the same and count how many watermelons you have in the field. Okay, so no need to design your own software. You just need the knowledge to really go into the open source community, find the good software that can be used for you. But this software is not ideal because it tells you how many watermelon you have or how many cells you have of the size you want, but it doesn't tell you which watermelon is good or which watermelon is bad. Okay, maybe a watermelon grow up to this size and then somehow it's bad, right? So you need to know better that how many watermelon that's good that I can sell to the market. So ImageJ can do part of the job, but not completely yet. But that's what he's going to do this year. Well, I'll show you right away. But also, once he did this, he caught the attention of many people, and one guy challenged him and said, "Can you tell me how many ducks you have in my farm?" How many ducks? And so he had the drone flown over the duck pond and then tried to count how many ducks he had. Can you, I cannot control from here. Can you try, there's a button here, it's animation. Can you try to move the cursor or mouse, and then there's a button here that you can activate the video. Maybe I need to go to back. Excuse me. I want to play the video here, just to show you how big the duck farm is. Excuse me, I'll do it. No, it's very. Okay. Now it's show. Now just have a feeling of how big the duck farm is. The ducks are white ducks. Yeah, I just picked up a question. How come they're all white? Because they're white ducks. That's a very big farm, duck farm, huh? Okay. Okay, up to here. So if you take all this video and put it into one picture, it's this big. How big the duck farm is this big. And so after image 3, it said there are 3,760 ducks in this picture. Okay, the duck farm owner was very happy because he didn't know how many ducks he had. So you might wonder, what's this got to do with AI or whatever? This is big data, obviously. AI, I'll tell you right away. This year he did even more. Okay, he took the drone, again, fly over the watermelon area in the eastern Taiwan here, Hualien area, and this is the spot that he wants to really focus on. Okay, so first of all, this is Google Map. He just superimposed all the drone taken picture over the Google Map, and then this is the watermelon field, very, very tidy, huh? High precision. If you fly the drone about 30 meters above the ground, you get about, for each pixel, 1 centimeter resolution. Imagine, 1 centimeter is resolution. You can identify the texture on the watermelon skin. This is how he is going to identify if a watermelon is good or bad. If a watermelon died prematurely, there won't be clear texture on the watermelon skin. You rely on the texture to identify if a watermelon is good or bad. Okay. And then you take the picture every few days just to monitor its growth. So here, this is the plants, 2 rows of plants. This is plastic cover on the ground so that the wild grass won't grow. And then in the future, each watermelon plant will grow this way or grow this way. Okay, so this is when the watermelon plant was just put in the ground. And then a week later, you see the watermelon is growing very unanimously toward one direction. This is a manual effort because you need to get the watermelon plants growing into the other direction over the plastic cloth. Okay, and this is actually what he intends to do next year, is that he wants to, based on this kind of image, he wants to work out some robotics that can help the farmer to really pull the watermelon plants toward the same direction. But this is so far doing by manual work, very, very tedious. Okay, and then this is another picture that all the watermelon has grown to cover all the plastics. Some of the areas are bright and some areas are dark because when the drone is flying over the watermelon field, the sun sometimes comes out, sometimes got blocked by the clouds, so the brightness is different. But actually, basically, you can still piece the pictures together and then see from this stage to this stage, the watermelon can grow, almost covering all the plastic cloths. Okay, And if you nail down further, you can see the farmers working here. Some of the watermelon is growing up. And then here, you start to notice all the watermelon start popping up. And this is a picture that even more watermelon, very, very clear. And then some of the watermelon which I put in red circle are the watermelon that's identified bad. It's not going to be harvested. Okay? So this is a very amazing work. And how did he do this? Initially, he has his own server, but the server, each time the server processes the picture taken from the drone, it takes almost half a day, more than 10 hours. I told him, why don't you go to Google and use the Google Cloud? He did that. He moved his software up to the Google Cloud and leased the machines that have the NVIDIA chips. And then about 12 hours of server time on his own machine nailed down to no more than 20 minutes or 30 minutes on Google Cloud. So that makes his computation more realistic and practical. He did not write too much his own software. 90% of his software was from public domain, open source. Drone very expensive. He bought it from Taobao, from China. Okay, Dajiang, a very well-known drone company, Dajiang. Good camera. I told you, when the drone is flying over a 30-meter altitude, the resolution is 1 centimeter per pixel. That's amazing resolution. I told him he had a problem because you need to superimpose the pictures from time to time, right? A week ago, this week, next week, and then the pictures has to be superimposed upon each other very, very precisely, so you know which watermelon is the same watermelon this week and next week. So from my civil engineering background, I told him, well, in civil engineering surveying, you have this 3-point positioning. That's, if you pick up 3 points nearby, you can identify very precisely where the location is. So he did that, and then he also worked out the image identification for watermelon. This is where the AI component comes in. Okay, I told you that you need to identify one watermelon from one rock. You need to identify a good watermelon from a bad watermelon by the texture on the watermelon skin. And then he was later invited to go to Indonesia, where Indonesia pineapple field was owned by a Chinese there. And that pineapple field has thousands and thousands of acres in Sumatra. And that watermelon field alone in Sumatra accounts for 20% of world supply of pineapple. Imagine 20% of world supply of pineapple from one pineapple field in Indonesia. And he was invited to work with that owner, a Chinese owner, and try to use the same technology to count pineapples. And if a compound pineapple is good or bad, okay? Business side, for farmers, the farmers doesn't have to negotiate with the dealer in terms of how many watermelon you have in your field, because in the past, no one can really pinpoint how many, just by gut feeling, 2 minutes left, okay? It should go quick. And for consumer now, he sells his watermelon on a website, and then you can pick the watermelon in the picture. Okay, I want this watermelon 2 weeks later, and then from that point on, you can watch the watermelon grow until you get the watermelon. So have this intimate feeling with your watermelon, okay? And this is really a marketing skill, strategy of skill. Okay, I got only 2 minutes left. How can US and Taiwan work together better? I mentioned earlier that all this can be done very, very easily using the infrastructure, cloud, big data, software, or artificial intelligence today. So this young farmer, he didn't go to college. He went to a junior college in Jiayi, and then he was able to do this. Okay, just innovation and ideas. How can Taiwan and the US work better together? Well, I think first of all, on the semiconductor front, in the future, AI chip architecture will be led by application features, and it has all the diversity that needs to go into chip. And Taiwan's semiconductor infrastructure is very good, flexible, timely, and can do this. One very crucial question is, leverage Taiwan's semiconductor fabs. Okay. My crucial questions here: is TSMC an ally or a competitor to U.S.? Unfortunately, at this moment in Washington D.C., you see all the lobby groups against TSMC, say TSMC is a monopoly, and of course, U.S. Intel has fabs, and U.S. also invests in another fab company. But obviously, in the industry, if you guys are in the semiconductor industry, you know that Intel is also having problem going to a very small scale, nanometer scale manufacturing. I think U.S. should really have an open mind and forget about having Intel develop its own fab capabilities, because in the future, when the AI chips become so diversified, I don't think Intel can really open up its fab to accommodate all the outside companies into Intel to manufacture all different AI chips. All those AI chips most likely will go to TSMC. So US should really treat TSMC as an ally rather than a competitor, and stop all the lobbying groups in Washington DC against TSMC. Okay, so this is very one crucial question. Right now, I think TSMC is, well, from Taiwan's perspective, we like TSMC to work very well with US companies in the future. Okay. Now, some other points: leverage Taiwan's big data strengths. For example, Taiwan's ubiquitous healthcare database. So that's a very treasure for medical service. When I was the Minister of Portfolio for Science and Technology, we funded Taiwan University Hospital, Taiwan University and Chang Hospital to really ask them to combine their medical school, hospital, business school, and try to figure out some innovation ways to use the medical service data for artificial intelligence. And a very major participant was IBM Watson. IBM Watson took part in the Taiwan University project because they thought this is a very major medical resource. But unfortunately, the human rights group at that time was very critical about this project, so the project got delayed severely. But nevertheless, IBM Watson now is working with Taipei Medical University again to work out medical applications. So this is a very example that domains intelligence. IBM Watson, a very typical top-notch US company, is working closely with either Taiwan University or Taipei University Hospital. Bring advanced pilot project to Taiwan. I mentioned earlier that the driving, okay, the intelligence driving in a mixed traffic environment is a very worthy project for Taiwan. Not only that, I think other advanced projects are very worthy to consider. Lastly, you might notice in the news that both Microsoft and Google said that they want to set up AI innovation labs in Taiwan. Okay, and Google even said that they not only want to set up labs in Taiwan, they want to train thousands of AI experts in Taiwan. Not just to recruit them. Some of them may be recruited by Google, but that's not the main purpose. The main purpose is to train AI experts in Taiwan through Google's know-how. So build tightly coupled AI research base and expose Taiwan youth to innovation culture. It's a good thing to set up AI labs or schools in Taiwan, but those young youths also need to be exposed to the culture here in Silicon Valley about innovation, about the motivation to startups, and so on. So I think tightly coupled AI research base is another area that Taiwan can use and work together. So my time is over. Thank you for your attention.